Hello. Good morning, students. This is Dr. Sumana from Department of Mechanical Engineering, Government Engineering College, Hassan. Today, this presentation is with respect to design of temporary joints, and in that it is knuckle joint. So the subject is design of machine elements for 5th semester mechanical students. The subject code is 18ME52. So the students learning this subject will be able to understand the various steps involved in the design process. They'll be able to understand and explain the principles involved in design of machine elements subjected to different kinds of loading conditions and forces. Okay, keeping various considerations in mind like strength, rigidity, functional and manufacturing requirements, etc. The student will be able to understand and interpret different failure modes and its application with respect to design of machine components. Okay. The student will be able to use national and international standards and will be able to develop the capability to design elements and components such as shafts, couplings, welded joints, riveted joints, etc. So this presentation is with respect to temporary joints. In the previous presentation, I have explained about what is a temporary joint, what are the different types of temporary joint. Okay, and in detail I have explained quarter joint and problems on that. Okay, so now we'll discuss about knuckle joint. So a knuckle joint is also a type of temporary joint. It is used to connect two rods subjected to axial tensile load. It may also be used to support compressive load if the joint is guided. Okay. But knuckle joint is not suitable for shafts for rotating shafts which transmit torque. So here, the knuckle joint mainly, the construction of knuckle joint permits relative angular movement between the rods about the axis of the pin. Knuckle joint is widely used to connect valve rod and eccentric rod. So here knuckle joint basically has three main components, that is eye, fork and pin as shown in the figure. Okay. So the eye is formed on one of the rods and fork is formed on the other. The eye fits inside the rod. Okay, the eye fits inside the fork and the pin is passed through both the fork and the eye. This pin is secured in its position by means of a split pin. Okay. The ends of the rod are made octagonal, so for a certain distance, okay, for better grip, and made square for the remaining portion or for some portion before it's forged to make the eye and the fork shapes. Okay. So advantages of knuckle joint is it is simple in design and manufacture. It has fewer parts comparatively. Okay. It is easy to assemble and disassemble. So coming to the design of knuckle joint. Okay. So the design of knuckle joint has a certain fixed parameters. So here in this presentation, the notations for the notations and the descriptions I have referred Design Data Handbook by Dr. K. Lingaya, second edition. Okay. So coming to the parameters of a design of knuckle joint, okay, we have capital F equals load in Newton, D diameter of rod, D2 diameter of pin, D3 diameter of pin head, D4 outer diameter of eye, B thickness of single eye, A thickness of fork, H thickness of pin head, sigma T is permissible tensile stress, okay, sigma C permissible or allowable crushing stress, tau permissible shear stress. Okay, so these are some of the standard notations used in the design of knuckle joint. Okay, so if you come to the equations here, so the tensile stress in the rod. So if you are referring Design Data Handbook by K. Lingaya, second edition, Figure 17.9 refers to knuckle joint. Okay. All the equations are defined with respect to figure 17.9. Okay. So here in equation 17.46, the tensile stress in the rod is defined. Equation 17.53 defines shear stress in the knuckle pin. The compressive stress in the eye due to bearing pressure of the pin is defined by equation 17.51. The stress in the eye due to tear is defined by equation 17.48. This tensile stress in the net area of the eye is defined by equation 17.47. Okay. The stress in the fork, um, 1 minute. Yeah. The stress in the fork due to tear is defined by equation 17.50. The tensile stress in the net area of the fork end is defined by equation 17.49. Okay. The compressive stress in the fork due to bearing pressure of the pin is defined by equation 17.52. Once we define all these parameters, then we find out the head diameter of pin D3, which is normally 1.5 D. The thickness of the pin head H is usually 0.5 times the diameter of the rod. Okay. So once we find out all the parameters, okay, we find out what is the maximum bending stress in the pin. Okay. So if the stress induced in the joint is less than the maximum allowable stresses, then we define that the design is safe. Else, we have to redesign or review the problem or numerical. Okay. So keeping this theoretical aspect in mind, okay, we'll just look into solving a problem so that we become familiar with use of design of knuckle joint. Okay. So coming to an example, so we have designed a knuckle joint to connect two mild steel rods to sustain an axial pull of 150 kilonewton. The pin and the rods are made of same material. Assume the working stress in the material as 80 MPa in tension, 40 MPa in shear, and 120 MPa in crushing. Okay. So once we read the problem, just students write down the given data. Okay. And preferably use notations as given in the design data handbook which you are referring. Okay. So here once we write down the given data, so here we have the load F equals 150 kilonewton, tensile stress sigma T equals 80 MPa, crushing stress, allowable or maximum crushing stress, sigma C 120 MPa, allowable shear stress tau 40 MPa. Okay. So now we'll see into what are the design aspects of a knuckle joint. Yeah. So first equation 17.46 defines the tensile stress in the rod. Okay. So in substituting the given values, we can find out the diameter of rod small d. Okay. Then equation 17.53 defines the shear stress in the knuckle pin. Okay. So this equation, from this equation we can find out the diameter of knuckle pin D2. Next, equation 17.51 gives the compressive stress in the eye due to bearing pressure of the pin. From this equation, we can find out the thickness of single eye represented by small b. Okay. Next, we have the stress in the eye due to tear. Okay, it is defined by equation 17.48. Okay. So from this equation, we can find out the diameter of the eye represented by d4. Next, using equation 17.47, the tensile stress in the net area of the eye. Okay. So here, from this equation, we can find out what is the tensile stress induced. Okay. If the tensile stress induced is less than the allowable tensile stress or permissible tensile stress, then the design is safe. Okay. So next, from using equation 17.50, okay, we can find out the stress in the fork end due to tear. Okay. So this gives the thickness of fork A. Similarly, using equation 17.49, we can find out the tensile stress in the net area of the fork. Okay. So again here, if the induced stress is less than the permissible stress, the design is safe. Okay. Now using equation 17.52, okay, we find out the compressive stress in the fork due to bearing pressure of the pin. Okay. So here, if the compressive stress is less than or equal to the crushing stress, the maximum allowable crushing stress, the design is safe. Okay. Then we find out the head diameter of pin D2, D3, which is 1.5 times the diameter of rod. Then we find out the thickness of pin head H, which is normally 0.5 times the diameter of the rod. Okay. So once we find out all the parameters, we find out what is the maximum bending stress in the pin. Okay. So in this case, we have found out that the maximum stress induced, okay, is much less than the maximum permissible stress. Okay. Hence, we can say that since the induced stresses are less than the allowable stresses, the design is safe. So students, with respect to design of knuckle joint, okay, first we write down the given data, okay, then we apply the equations as defined from equation 17.47 to 17.555. Okay, so this will give us the various parameters of a knuckle joint. Okay, so here basically we have problems similar to the one solved here. Okay. So here, after this module, the student will be able to understand the various steps involved in the design process. Okay. What are the principles involved in design of knuckle joint or temporary joints? Okay. What are the different factors to be considered with respect to strength, rigidity, and requirements? Okay. The student will be able to understand and interpret different failure modes, okay, and how and where it can be applied. Okay. So he'll be able to develop the capability of designing elements such as quarter joint power screws, threaded fasteners, okay, and similar other components. Okay. So students, thank you for watching this presentation. If you have any queries or doubts, please feel free to mail me, okay, at my given email address. Okay, thank you.